D and A block element से देखो for starting D and A block elements, what are the standard reduction potential? We should know standard reduction potential for this purpose. Trends in M2 plus M, the standard reduction potential by electrode potential. What is that? That is the sum of enthalpies of sublimation, ionization is not balanced by the hydration enthalpy in case of copper. Why? Reason for the unique behavior of copper, due to the positive standard reduction potential, copper is unable to liberate hydrogen from the any acid, hydrochloric acid. And there is a trend, that's been a graph, you can explain this. The red one is the observed values and green one is the calculated values. Here, that is actually calculated value is lower than the observed value. Why it is, and what is the difference and why this difference occur? Actually, due to the unpaired electron and its stability, okay, that's been exchange energy. For the exchange energy, for the number of unpaired electron, the stability may vary. So you can say the value of standard reduction potential are more negative than expected due to the stability of half-filled subshells in manganese 2 plus and completely filled D10 configuration in zinc 2 plus also. For this reason, the standard reduction potential is more negative because this is very stable. The values of the reduction potential is like this. You know already that for manganese 2 plus, the D subshell is half filled, that is D5, and for zinc 2 plus, that is D10. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. These are the 4th period D block elements. Atomic number 21, 22, 23, 24, like this. And that's reduction potential like this. Okay. So atomic number 21, 22, 23, 24 up to 30. This is the reduction potential. This is negative, and up to this there is a positive. So copper has the positive standard reduction potential. Okay. So this is the fact, and here it is also standard reduction potential is positive here. For this reason, copper is unable to displace hydrogen from the any hydrochloric acid. So the low value of reduction potential for scandium reflects the stability of scandium 3 plus, Sc3 plus, which has a noble gas configuration. The highest value for zinc is due to the removal of an electron from the stable D10 configuration of zinc 2 plus. So zinc 3 plus is not stable and it is unable to form because the highest value of zinc is due to the removal of one electron from the stable D10 electronic configuration. The comparatively high value for manganese shows the Mn2 plus, that is D5, is particularly stable, whereas comparatively low value for Fe shows that extra stability of Fe3 plus, because Fe3 plus is half filled d orbital is there, and for manganese 2 plus it is half filled d orbital, so both are stable. Now the highest oxidation number are acid in titanium X4, that is tetrahalides, vanadium pentahalide, chromium hexahalide, like this, VF5, CrF5. Okay. The stability of fluorine to stabilize the highest oxidation state is due to the either higher lattice energy, as in the case of cobalt fluoride, trifluoride, or higher bond enthalpy values for the higher covalent compound. Example, VF5, CrF6. Now this is the oxidation state. In the first class, we already know about the oxidation state, and we already calculate the number of oxidation state possible for d block elements. This is the example of compound which may form plus 3, plus 5, plus 4, plus 2, plus 1, like this. Another feature of fluoride is their instability in the low oxidation state. That is Vx2, that is X means chlorine, bromine, iodine, and the same applies for CuX2. Cu2 plus oxidizes I minus to I2. That's mean copper can reduce, but the copper 1 plus here copper is 1 plus, and here iodine is 0, that is minus, that is 0. So oxidation number increases minus 1 to 0, that is oxidized occur for iodine and reduction occur for copper. This is the copper 2 plus, and here copper is plus 1. Copper plus 1, that is copper 1, compounds are unstable in aqueous solution and undergo disproportionation. That means disproportionation means copper 1 can convert copper 2 plus and only copper, because copper 1 plus is not stable in aqueous solution. So it can convert Cu2 plus to Cu. Okay. So Cu plus, from this Cu plus, this is Cu2 plus Cu. So this is the disproportionation reaction. Why it is disproportionation? Because oxidation number here increases and from here to here decreases. The stability of copper 2 plus rather than Cu plus in aqueous solution is due to the much more negative, that is hydration enthalpy of copper 2 plus than Cu plus, which more than compensates for the second ionization enthalpy of copper. Second ionization enthalpy means copper plus to copper 2 plus. So copper 2 plus in aqueous solution more stable than copper 1 plus. Chemical reactivity and reduction, standard reduction values. Okay. Chemical reactivity and standard reduction potential values. E0 means standard reduction potential. So the E0 values for M2 plus M indicates a decreasing tendency to form divalent cations across the series. This generally trends towards less negative E0 values is related to the increase in the sum of the first and second ionization enthalpies. E0 values for Mn, that's manganese, nickel, and zinc are more negative than expected from the general trends, whereas the stabilities of half-filled D subshell in Mn2 plus and completely filled D subshell in zinc are related to their E0 values. How? Manganese, nickel, zinc have more negative E0 values than expected. Why? So manganese, nickel and zinc have more negative E0 values than expected value. E0 value means standard reduction potential value. Standard reduction potential value like this. Actually meaning ta ki देखो और copper 2 plus থেকে কপার হবে তার মানে আমরা কি লিখতে পাচ্ছি Cu 2 plus 2 কপার এইভাবে লিখতে হয় আর এটা যদি আমরা E0 লিখি এখানে দ্যাটস মিন E0 অফ কপার 2 plus to কপার মানে কপার 2 plus থেকে কপার হচ্ছে তার একটা ভ্যালু আমরা যে ধরলাম 0.34 ভোল্ট ওকে সো এটা এইভাবে আমরা লিখি clear for nickel E0 value is related to the highest negative enthalpy of the hydration. Based on the E0 values for the redox couple means there is a oxidation reduction. That's mean copper 2 plus copper. It is also a redox couple. M3 plus M2 plus. It is also a redox couple. That's mean which can accept and donate electron. This pair is known as redox couple. So M3 plus M2 plus shows that M3 plus and CO3 plus are the strongest oxidizing agent in aqueous solution. The ions titanium 2 plus, vanadium 2 plus, chromium 2 plus are strong reducing agent and will liberate hydrogen from the dilute sulfuric acid or any hydroacid like chromium 2 plus 2H plus or 2HCl or H2SO4 like this. It can readily oxidized. That's been copper from chromium 2 plus to chromium 3 plus and to liberate hydrogen from the acid. Consider two ions bars. Iron bar আমরা যদি দেখি দুটো iron bar that is under the influence of magnetic field. One is influence of magnetic field. Now attracted by the magnetic field, repelled, no action, attracted. So what happened? Under the influence of magnetic field, the substance which move towards the magnetic field are called paramagnetic. Okay. The substance which moves towards the magnetic field are called paramagnetic. So substances which move towards magnetic field is called paramagnetic, and substances which are strongly attracted towards iron metal are called ferromagnetic. Magnetic moment. What is the magnetic moment? We can already calculate magnetic moment is equal to root over n into n plus 2, that is n is the number of unpaired electron. So paramagnetism arises due to the presence of unpaired electrons is such electron having a magnetic moment, spin angular momentum and orbital angular momentum. So magnetic moment we can calculate in this way, that n into root over n into n plus 2 Bohr magneton. Bm means Bohr magneton. N is the number of unpaired electron of any element or atom or ions also. And this is the magnetic moment for different ions scandium 3 plus, since it contains zero number of unpaired electron, hence its value is 0. This is titanium 3 plus. The magnetic moment is root over 1.37. It is calculated and observed is 1.7 to 1.8. Why it is? Because there is a 1 ampere electron, root over 1 into 1 plus 2, that is root 3. The value of root 3 is equal to 1.73. D subshell has dash number of orbitals. Okay. D subshells dash number of orbitals. Which one is the correct? D is 5 orbital is there. D subshell contains 5 orbital is there. What kind of substances are strongly attracted towards a magnetic field? What kind of substances are strongly attracted towards a magnetic field? That is ferromagnetic. Ferromagnetic is highly attracted by the magnetic field. That is ferromagnetic. What kind of substance is deflected away from the magnetic field? Deflected. That is diamagnetic. Okay. The formula for calculating magnetic moment 3D series is root over n into n plus 2. Okay, n into n plus 2. What is the unit of magnetic moment? That is Bm, Bohr magneton. Color of compounds. Why? The compounds of d block element is color. What strikes in our mind as soon as we hear it? That is gives you or like. But have you ever wondered why we see this type of colors? Generally, we had heard that we see color due to the reflection. Like this is the reflection. That's when from the bulb, light comes to this point and reflected towards eyes. So, but this theory later on proved to be a failure. Hence, next theory has been proposed. Okay. So, but this theory later on proved to be a failure. Hence, next theory has been proposed. That's been actually transition of electrons from one orbital to another orbital. The new theory suggested that we see the color which is complementary to the absorbed color. That's means if this is yellow color, okay. Find a complementary color, we can take help of Malshin wheels. What is this? Malshin wheels. It's like this. Means here. Like gives you. Violet and yellow. Blue and orange. So what is this? This theory has been ruled out as it could not explain the existence of color like pink, brown, etc. So we can explain by the transition of electron. So next theory that came up considered totally a new concept. As we all know, we have 5d orbitals like this. This is the orbital 1, 2, 3, 4, 5. So from this 5 orbital, if there are electrons, that's mean let's consider we have one electron in the d subshell. it can transit. That means when electrons from other atoms or molecules approach these d orbitals, the 5d orbitals split in two energy levels. That is, there is a axial and there is another equatorial. XY, XZ, YZ, that is two plane, and there is another plane, that's mean dz square, dx square minus y square. So there is two types of orbital. It is known as crystal field splitting. Okay. So what is this? There is one electron. So this electron comes here, and if we supply some energy, then this electron supplies from energy. This electron can transit from here to here, and it can radiate some energy, or it comes from upper level to lower level, emit some energy. So absorption band or emission band appears, and which will be a color. Now, when energy is applied, already discussed, from lower energy level gets excited to higher energy level, and energy absorbed by this electron. And this is an absorption spectra, and it is also known as d-d transition. From d orbital to d orbital, electron transit, that is d-d transition is occurred. As we all know, higher the energy, lower is the stability. In order to attain stability, electron in the higher energy level emits energy and comes back to the lower energy level. The energy emitted, if its frequency matches with that of color is visible spectrum, we see the color. Okay. So this is the emission of energy. This comes out, and if its wavelength is similar to red light, then we can see it red. The energy emitted, if the frequency matches with that of color is visible spectrum, we see color. So what happened? The transition element and their ions exhibit color due to the presence of unpaired electron in d orbital and d-d transition. The color observed corresponds to the complementary color of the light absorbed. Some oxo anions like manganate, permanganate, MnO4 minus, this is permanganate, chromate, Cr4 2 minus, dichromate, Cr2O7 2 minus, exhibit color due to the charge transfer phenomenon. Here, d-d transition is not occur, but manganese to oxygen, oxygen to manganese, this is charge transfer. What is charge transfer? Complex like this. There is a double bond, there is a single bond. Okay. So it is manganese, then it is +7 state. So d orbital is 0 here. Oxidation state is 0. So this type of complex formed by charge transfer, that is from the oxygen to manganese, that is charge transfer occurs. So for this reason, this type of compound shows color. This is pink color. Okay. Permanganate is pink color, and it arises from the charge transfer of the oxygen. Okay. Color of some of the first row transitional metals ions. What is this? Configuration d0, d0, scandium. So since there is no d orbital, a d electron, hence it is colorless. There is no transition of electron. But it can form when charge transfer complex is formed, then it may arise color. But without d electron, there is no color. Zinc, you know, zinc 2 plus compound, that's zinc carbonate, zinc sulfate, all are white. There is no color because there is a 3d10 completely fill up for zinc 2 plus ions. So D, if D is completely filled up or D is empty, then there is no color. So D0 is a colorless compound. D1, since there is a 1 electron, titanium 3 plus, there is a 3d1 electron, so it is a color compound, it forms purple color compound. D1, vanadium 4 plus is blue color. D2, vanadium 3 plus, it is green color. So like this. There are so many colors. When chromium 3 plus, that's mean D3, it is violet. D4, manganese is violet. D4 for chromium, it is blue color. Manganese 2 plus, pink, and and of course manganese 7 plus for charge transfer complex, it is also pink, like this. So color arises from the d-d transition. That's mean electron from one d orbital to another d orbital transition occur and colors arise. So which of the following ion is green color? Its aqueous solution is nickel 2 plus ions. Which of the following ion is yellow colored in its aqueous solution? Which one? Iron 3 plus ion. Formation of complex compounds, catalytic properties. Complex compounds are those in which the metal atoms or ions bind to number of anions or neutral molecules, giving complex species with characteristic properties. Example, FeCN6 3 minus, FeCN6 4 minus, like this. These are all color complex. Complex formation is due to the completely smaller size of the metal ions. There are high ionic charges, the vacant d orbitals availability, and how it can act as a catalyst. You know, eating of junk food, digestion and stomach act like this. To overcome indigestion and loss of appetite, whom do you visit? Doctor. That is children's specialist doctor. Or we can take pepsin. Okay. So what medicine is prescribed by the doctor? That's like a pepsin and multivitamin also. What is pepsin? Pepsin is a protein and pepsin is an enzyme. Enzymes are biological catalyst. It can digest this type of foods. Pepsinogen is present in pro-enzyme form. In presence of HCl, it converts into pepsin to act on proteins for digestion, thus overcome indigestion in children. So protein plus enzyme, enzyme surface with active centers and readily capture, and it gives product, that's what digestive product. Many metals and their compounds can act as catalyst. These are called inorganic catalysts. Many, that's inorganic catalyst like free valence electrons, ability of d orbital, large surface area of the compounds, variable oxidation state like manganese. As a result, their ability to adopt multiple oxidation state and to form complex integrations. Catalytic properties, the transition metals and their compounds are known for their catalytic activity. Example, this is referred to their ability to adopt multiple oxidation state and to form complexes like vanadium oxide in contact process, finely divided iron in Haber process, nickel or hydrogenation of vegetable oils to get banaspati ghee, lead-like catalysts like PD, barium sulfate, reducing agent in this hydrogenation of alkenes and alkynes. The transition metal ions can change their oxidation state, so they become more effective as catalyst. Iron 3 catalysis and reaction between iodide and persulfate ions like this. S2O8 2 minus is the persulfate or per disulfate. Mechanism of the reaction is Fe3 plus. It can accept one electron to form Fe2 plus. Clear? Like this. Why do we see color in transition complexes? Because of the crystal field splitting, because of d transition. So all of this, that's because of electron emitting energy from higher energy level in variable region of the electromagnetic spectrum. The splitting of d orbital is called as d transition splitting or crystal field splitting. That's crystal field splitting. Catalyst increases the rate of reaction and number of reactant reacting. Okay, no problem. Number of reactants reacting. In which form solid catalysts are used? Finely divided powder, it may be better. Okay. Formation of interstitial compounds, alloy formation. Where is it placed? We have heard that nothing is 100% pure. Even the purest gold is 99.9% pure. What is that of 0.1% impurity for n atoms? That's when there are so many gaps in the solid state. In this gap, there are so many impurities there. This is known as intrinsic compounds. So in this interstitial position, that's mean the gap. This gap is known as, there are so many gaps there, which is known as interstitial position. And in this interstitial position, if there are some impurities, that's mean foreign elements, is known as interstitial compounds. The finite composition cannot be represented. The atoms that are trapped are not too large or too small. They are nearly of the size of the void. So this is also known as void. Interstitial position, that's also known as void. This void can fill up by the foreign elements like this. copper, zinc, copper, zinc, copper, zinc, and two metals form alloy, the mixed molten state. When it is mixed in the molten state, if there is interstitial position is vacant or from the other element it can occupy, then it is known as impurity or interstitial position. Okay. And for this reason, the impurity occurs. The transition elements have the tendency to form alloys due to the similar size of all elements. Due to this, the atoms of one type are replaced by the other type in the crystal lattice. The atoms are replaced only if the difference in atomic size is plus minus 15%. Characteristics of alloys are hard. Some fluorides approach diamond in hardness. They have high melting point, higher than those of the pure metals. They retain metallic conductivity. They are chemically inert. So, what are the characteristics? So, what is this? The empty space between the atoms or ice particles or force of attraction? None of this. So, empty space. The composition of the impurity is fixed for the interstitial compounds. Which one is correct? Composition of the impurity is fixed for the interstitial compound. True, false, sometimes. Okay. The composition of the impurity is fixed for the interstitial compound is true or false. That is false, because this is not fixed, because there are so many positions there. Some position can fill up by the foreign element, some may vacant, okay, remains vacant. Which of the following is a property of alloys? It is hard, no problem. It's high melting point, so all of these are less ductile. The foreign particles trapped inside interstices are very large, no? It's very small, nearly the size of the interstices. During the formation of alloys, atoms are replaced only if the difference in the atomic size is plus minus 15%. Thank you.